Let's try to solve this problem here. A homemade rocket is moving at a speed of 45 meters per second. So I believe this is the homemade rocket over here, moving at 45 meters per second. Let's write it down. 45 meters per second. The rocket breaks into two pieces of equal mass. So right now, this is half of the rocket and this will be another half of the rocket, and they should both have the same mass. So to write it down, I'll call this as M1 because they label V1 over here. They label V2 over here, so this will probably be M2. And I would like to state that M1 here will be equals to M2 because they are equal in mass. Therefore, they should be equals to M. Okay, M is just a general term just to say that they have the same mass. That's why we can represent them with the same symbol, which is M. Okay, so which fly off with velocities v1 and v2 in the figure above. So you have m1 moving at v1 in the upper right quadrant, whereas m2 moving at v2 in the lower right quadrant. Okay, determine the value of v1 and v2. So now they ask us to determine what is v1, what is v2. Well, this is a typical principle of conservation of linear momentum question, because initially you have an object or two objects. In this case, it's two bodies connected together. M1 and M2 connected together, they become one single body moving at a certain velocity. Then after that, this is called explosion. So explosion occur. That's why M1 move in one certain direction with a certain speed, M2 moving in another direction with another speed. Okay, so let's try to determine V1 and V2 right now. Okay, so this is a 2D question, so we know that in both dimensions, the x dimension and the y dimension, our linear momentum should be conserved. So sum of P x initial should be equals to sum of P x final. So this is the x component of momentum being conserved. At the same time, we should also know that the y momentum is being conserved as well. So sum of Py initial is equal to sum of Py final. Both of these should be conserved. Okay, we know that there are two bodies here, so the sum here represent two bodies, M1 and M2. So you have your Px initial of 1 plus Px initial of 2. Okay, 1 here represents object 1, M1. 2 here represents object 2, M2. Okay, so you have your Px final for 1 plus Px final for 2. Okay, so we break the sum over here into two objects. So we do the same here for y, so it will be Py initial of 1 plus Py initial for 2 is equals to Py final for 1 plus Py final for 2. Okay, so you can break it open. You know that momentum is just a product of mass and velocity. So this case is mass m1 multiplied by the x component of velocity for object 1. So this one will be ux1. Why do we call it u? Because it's initial situation. Okay, this one will be m2 ux2. The other side will be m1, but this one will be v because this is the final situation. vx1 plus m2 vx2. Okay, you can further open the y as well. Okay, I'm not sure why do I do it at the same time. I can do x first then do y, but since I'm doing it like this, I'll just continue. uy1 plus m2 uy2 is equals to m1 v. Sorry, this is v. vy1 plus m2 vy2. Okay, so now it's just substitution. You know that mass 1 and mass 2, we can represent them with the same symbol m, so we just represent them with m. You know that initially m1 and m2, they belong to the same object. They are two parts of the same object, so they should be moving in the same way initially. So when they're moving in the same way initially, that means by they are moving at 45 meters per second to the right. Okay, so we can do substitution here. Every time we substitute something, we have to make sure the sign is correct. So this case, we should not just put 45, because that means when we haven't really checked the direction yet. We check the direction, 45 meters per second is to the right. Therefore, we can put it as x component being positive. Okay, m here also being positive. Okay, now when we are dealing with the final here, we know that final, they are not moving in the x-axis, not moving in the y-axis. Because of this, it is more appropriate for us to resolve first actually before we do any substitution. So if we resolve this, then we can break this into one component over here, the x component, then our y component here. Okay, so we can call this being 60 degree. Okay, you can probably see that this is something like this. If this is 60, then this should be 60 as well. Okay, so now if you break this, 60 is near the x component, so the x component will be cos v1 cos 60. So this one will be v1 sine 60. But before we proceed further, let's determine the sign as well. This v1 cos theta is moving, it's pointing to the right, therefore it's the positive direction, so positive v1 cos 60. v1 sine 60 here is pointing upwards. Upwards is the positive direction in y, so this one will be positive v1 sine 60. It's good that we label the sign first, so that later when we substitute, we will recall that we need to bring in the whole sign as well into our substitution. Okay, it's just a good practice. So let's do it for y, for object 2, sorry. Object 2, v2, you can split into the x component. Of course, you also have your y component. Okay, so 30 will be over here. So this one will be near 30. So this one will be v2 cos 30 degree. Again, it's a positive because it's pointing to the right. Whereas v2 sine 30 over here, v2 sine 30, because it's pointing downwards, that's a negative in the y component. So this is negative v2 sine 30. Okay, so now we are clear with which one is positive, which one is negative. We've resolved all the velocities already. Now we go back to our substitution. So m1 again is just m vx1. Vx1 will be object 1, the object on top, the x component of object 1, x component of object 1. So this is the x component of object 1 plus v1 cos 60 degree. So this is positive v1 cos 60 degree. Okay, continue. We have vx2. Vx2 here, sorry, let me remove the 2 over here. Vx2 over here is just object's 2 x component velocity. Object 2 x component of velocity. So that's positive v2 cos 30. So let's write it down. Positive v2 cos 30. So now we are done with all the substitution. We know that all the m can cancel each other out because there's m in all the terms over here. So now what you are left with is just on your left hand side, there's 45 plus 55, that is 90. On the right hand side, you have cancelled the m, so you are now left with v1 cos 60 degree plus v2 cos 30 degree. Okay, so right now there's two unknown over here, v1 and v2, and that is actually what they want to determine the value of v1 and v2. Okay, so let's continue with the y component. Right now, y component, you have m1, so m uy1. Okay, u is initial situation, y the y component of velocity for the initial situation. Initially, the object is moving to the right, so there's no y component because an object has no parts of it moving upwards, there's no parts of it moving downwards. So in that case, you can say the y component of initial velocity is just 0. Because it's not moving upwards, it's not moving downwards at all. So uy2 is also 0. So m1 vy1. So now object 1 y component. Object 1 y component, that's positive v1 sine 60. So positive v1 sine 60 degree. Okay, plus m vy2. Vy2 is object 2. Object 2 y velocity. Y velocity is negative v2 sine 30. Negative v2 sine 30. Okay, so now you have completed your substitution. Again, all terms have m, so you can cancel out m. So right now, if you conclude the sentence, I believe you will be left with 0 is equals to positive v1 sine 60 plus, oh no, plus is a minus right now, negative v2 sine 30. Okay, so right now again you can look at the equation and see that there's two unknown over here, v1 and v2. So we have two equations, both with two unknowns. Two equations and two unknowns, you know that the next step that you should be taking is to do simultaneous equation. You can do it probably using substitution method or any kind of methods that you prefer. You will not need to show the working on your paper because it's a simple simultaneous equation. You can straight away use your calculator to calculate it and you can just generate the answer. So I already generated the answer using calculator. So your V1 will be equals to 45 meter per second, whereas your V2 will be equals to 77.94 meter per second. Okay, both of these values should be positive. You should not get a negative value. Negative value will make no sense over here because here is the hypotenuse. What you're putting in is the hypotenuse. So hypotenuse should not have any direction, so it should be just positive value. Okay. So this will be V1, this will be V2. So V1 here is moving at 45 meter per second, whereas V2 here is moving with 77.94 meter per second. So this is how you solve a question involving conservation of linear momentum. Thank you.